Hi guys, welcome to Just Coding YouTube channel. We are seeing series of lead code problems. So today we have one challenging lead code problems. Let's see how we do it. Okay, today's problem is the problem number 23. The title is merge k-sorted list. Okay, let's see the description. You are given an array of k linked list. Okay, each linked list is sorted in ascending order. Merge all the linked list into one sorted linked list and return it. Okay, it's nothing but array of linked list. Okay, all you have to do, you have to merge it. Okay, so if you want to merge it, what would be your brute force approach? Let's say, take this as an example. Oh, sorry. Okay, 145, 134, 26. Okay, so we have, it could be any number. Okay, it's an array of linked list. It could be 100 or lakhs. Okay, so what you do as a brute force approach, you take the first value of here and here and here and so on. Okay, take the first value, you compare, whichever is lower, you add to the new linked list. Okay, then whichever is got, let's say this one is lower, this alone you move to next pointer. Okay, then again you continue the process 4 to 1, 2. Then this will be get hit. So this will move to here. Then 4, 3, 2. Then 2 will get moved here. Okay, then 4, 3, 6. So what happens is this 4 almost got travels almost like 3 times. Okay, each time it gets repeated. Okay, let's take an for example. Okay, let's see how you do this scenario. I have um, like 1 to 1 lakh. Okay. And the second thing is 1 lakh 1 to 2 lakhs. Okay. Then 3 lakhs 1 to 4 lakhs. Then 4 lakhs 1 to 5 lakhs. Let's say this is my array of linked list. Okay. What you do, you just compare this, and again two, this. Okay, then three with 2 lakhs one, 3 lakhs one, 4 lakhs one, then four with 1 lakh one, 2 lakh one. So it goes on. Okay, even though everything is size is 1 lakh. Okay, you just think how many iteration you're gonna do. You're gonna do almost like 4 lakhs iteration. It's a four times of your size. Okay, this is not an optimal way of doing it. Okay, that's why its brute force approach will not work for this. That's why this has been categorized as hard. As you can see, this is not an easy thing. It's been categorized as hard because unless you do the smarter way, for small numbers, it will always work. Okay, and one more thing, whenever there is a problem, always think as a larger perspective. What happens if they give a millions of array? What happens if it's each array has the billions of data? Okay, nobody wants to have like a size is 3, each length is 5. Okay, nobody wants that. So that will be whatever approach you do, everything almost even a P4 computer will give the result in a milliseconds or seconds. Okay, so that's not what they wanted. Okay, what they wanted is, will your approach will work in a large data? Okay, is this optimal? So that's the thing you always have to think. Okay, don't think that for 5 numbers, it's for 100 numbers, it will work, no issues. It gives a milliseconds output. So what's the harm? No, don't think like that. Always think as a broader perspective. Okay, let's see how we plan to do. Okay, let's assume, okay, I have four arrays like 1, 5, 8, 15. Then 2, 4, 9, then maybe 20. Then, sorry, oh my God, 3, 20, 30, 40, 7, 8, 9, 10. Let's say this is our data. Okay, what we have to do is our approach is going to be break down the number of lists into half. Okay, we have four items in an array. Okay, so I want to do like merge these two. Okay, then merge these two. So I'll give one merge link list one, then this is merge link two. Then merge these two. I get one merged linked list. Okay. So this is what we're doing. We are going to take in a pair of linked list. Okay. Even the how many numbers you have at 100 or 200. Okay. Take two to pair. Okay. Merge, merge, merge. In the next iteration, whatever the results come, right, you take again, you do the merge, merge, merge. Okay. This is kind of a recursion kind of thing. Okay. So unless you get one single linked list, okay, you do the process repeatedly. So that's how we going to do it now. Okay. And we should, the merge mechanism also should be proper. Okay. The many people, what I see the mistake is, let's say, this is what they do. Let's say 1, 2, 3, 4, 5, 6. Let's say this is your thing. Compare these two. Okay. And if whatever the lesser they put again 2 and 4, 2, then 4 and 3, 3. Okay, then even though it's nothing is there, right? Okay, but still they go one by one only. Okay, so it's comparative of 5 less than null, then 6 less than null. Okay, even though there is no number in that, they still try to check with a null. Okay, since they put it one for loop, that's it. Okay, the problem with this approach is, okay, what happens is, let's say I have only two items in this, but here I have 2 lakhs. What you do? You're going to first two things you check. For every 2 lakhs item, you're going to check with a null. That's not a way. Okay. So what you can, the moment it reaches null, either one reaches null, you take the full remaining part of the other. So that's how you do the merge linked list. So we have two concepts here. One is how we do the linked list, take a two pair, how we merge it. That is one phase. Second phase is take a two pair of every linked list and merge it, then until you get a one. So this is the two operation we're going to do. Okay. Let's see how we do it in the code. Okay, let's say I take the C sharp since I'm good with C sharp. As usual, the moment I get start with the method, I always check for it is null or empty. If it is zero, just return null. Okay, then let's straight away write our merge merge method. Okay, let's say merge nodes, this node L1, this node L2. Okay. So, and whenever they ask you to merge a linked list, okay, your first thing is create one dummy node. I'll explain you why. Okay, let's go here. Let's assume, okay, you have 1, 2, 3, 4, 5, 6. Okay, you have one empty merged node. Okay, this is merged one. Initially, it's empty. So you have 1 and 4 compare. You put 1 here, then you 2 and 4. Like you go on, go on. So the current node, okay, the merge linked list node will go on, go on, go on. So let's say finally you added the 6. Okay, fine. Your current list node will point out the 6. Okay, but I want to point it here. If you just add it and set it move on, let current card next equal to this and this. If you move on like this, finally your current node will be pointing to 6. Then how you backtrack? So again, it's be troublesome. So what we do is we create a dummy, okay, and we assign this to one current. So both has dummy now. This is dummy and this is current. We have two variables. This current is our merge node. Okay, so we just move on, move on, move on. Okay, but this zero, whatever we have, right? This zero, it's still in the dummy. So, and it's what we did is current equal to dummy. That's how we first assign. So this has some link. what I want to return is I just return dummy dot next. Why? Because this current has gone. Okay, the current will be like 1, 2, 3. So what is the next of the dummy? So both points to here. This current also points to 1. This dummy also points to 1. At initially, first stage, whenever I add the first item, both points to 1. But the current will go on to the 6 eventually. But the dummy will still point to the 1. That's why we take this as dummy always. Okay. Maybe when I write the code, you get understanding better. Create a list node, add current, and assign the dummy. Okay. Now dummy and current points to same node. Okay. When you return it, dummy dot next. What happens is dummy dot next is whatever the first node you add to your merge list, that's what the dummy dot next. So it's obviously 1 or the very lowest number when you merge it. Okay, that's where it points. So that's why we return dummy dot next. Okay, let's see how we write. We write while if both are not null, L1 not null and L2 is not null. When both list node contains some value, okay, I can check like L1 dot value less than L2 dot value. If L1 is lower, what I'm going to do? Current dot next will points to L1 and L1 will just move one step ahead. So L1 dot equal to L1 dot next. Same for the L2. If L2 is lower, L2 points to L2, L2 equal to L2 dot next. Okay, we assigned one. And we have to move our current node also. Current equal to current dot next. Okay, so current merge node also points to next node. It's waiting for the next lowest number. Okay, so this is how, when it will happen. So when both are same size. Okay, let's say L1 is let's say five items. L2 has 10 items. In that case, it will iterate for 5 times. For the remaining 5 times, it will just break it and come out. So in that time, what we are doing, let's say which one become null. If L1 is not equal to null, what I'm going to do is current dot next equal to L1. Else, if L2 is not equal to null means if both are same size, this both case will be failed because both has been reached its limit and both is null. So this will be unreachable. If only one of them is null, one is not null. Let's say if L1 is not null, what we are doing is we are just pointing current on is equal to L1. So whatever the remaining nodes will be just linked to the current node. Okay. And finally we are okay. Did I write? Yeah. Finally, we retain W not text. Okay, so this merge node is done. Now we go for here. As I said, we're going to split the list node, okay, list array into off. Then each time we break to the off. Okay, so how long are you going to try? Unless it's greater than 1, the length is greater than 1, I'm going to do that process. Okay, that's why I'm putting length is greater than 1 and until it's not 1, okay, it's greater than 1, do this process repeatedly. So what I'm going to do is I'm going to create one temp merge nodes. Okay, new list node list dot length plus 1 by 2. Okay, so what I'm doing is I want to create a new merged linked list array, okay, which is off size of our current node. Let's say our node is has array has 3 values. Okay, I want to bring that to 2. 2 is not why, because 2 I want to do the ceiling. That's why I'm putting plus 1 then divide by 2. Okay, I don't want to 3 becomes 1. I cannot do that, right? So 3 will become 2, then 2 will become 1. That's the obvious way. So that's why I'm putting length plus 1 by 2. So I want to do the ceiling, not flooring. Okay, now I got it. Now we go for the for loop and I equal to 0, I less than list dot length, I equal to I plus 2. Why I plus 2 is I'm going to take two list node. Okay, I take a pair. Okay, so list node L1 equal to list of I, list node of L2 will be, let me assign by default null. If I plus 1 less than still length, then I assign L2 equal to list of I plus 1. So this I take two list node. Okay, I got two pair. What I'm going to do is, let's say I go to create one more variable int index equal to 0, temp merge nodes of index equal to merge nodes. We are calling our method L1 comma L2. I'm incrementing the index. Okay, so how long this will do until the list becomes off, right? So I need to update the list. So what I'm this temp list is nothing but our, let's say we have 4 items, now it's become 2 now. Okay, the 2 I want to reassign to the list. Okay, so what I'll do, I'll just list equal to temp merge nodes. So it means now this is your new list. Okay, do the process again. Do again have a off size of the temp merge node, and again take the pair of thing. Again do that. Okay, it's kind of a recursion thing. Okay, that's where we are assigning our temp merge node to list here. Okay, and finally, when it will break, when the length is 1. When the length is 1, I'm going to just return list of 0. Okay, let's run it. Hope there's, oh god, there is some, oh, there's typo error. It should be list node. My god, where I am played. Why? My god, I'm doing so much typo error. Yeah, it's been accepted. Let's submit. Oh, it's 90 seconds and beats 81% of the users with the Shisha. Okay. And for a lead code, forget about this times and okay, this is always oscillating. Okay. Even though let's you go to this whatever the person, right? You copy this code entirely and paste it here, run it, it won't give the 73 seconds. So it depends on the node where our code's running. You know the nodes concept, right? So whenever you try to run this program in cloud, it goes to some system and try to run this. Okay, it's not always going to be same system. It's going to be different system, and different systems going to be the different configuration, different OS, different RAM. It's going to be so many factors in that. Okay, so don't worry about the thing. So as long as it's in and around plus or minus 20 milliseconds, it's fine. Okay, so it's almost like you are similar to this person only. Okay, okay, guys. So that's it for the thing. So even though it looks hard, the category is hard. If you understand the list node concept, it's very straightforward. All we did is very simple steps we took. Okay, for a workaround, for a overview, I'm saying again, break the array into half. I mean, take the pair, merge it, then do the process again. Take the two pair, merge it until you reach one. As simple as that. Okay. Okay, guys. If you have any questions or if you want to try a different program or you stuck with any problem and you want the explanation, please let me know. I'll create a video of it. Okay. See you in the next video. Thank you.